acid plus a base. So this is the most generic form. And even though I'm out of frame, I'm going to point to the pH table here. At the top, 7 through 14, we've got the bases. Below 0 to 7, we've got the acids. Acid plus base equals water plus a salt. A salt. We know that NaCl is a salt. And typically these metals, a lot of ionic compounds are salts. Potassium bromide, example of a salt. Potassium chloride, very definitely an example of a salt. You can even get, because our bodies need potassium and sodium and chlorine, you can get 50-50 blends of NaCl and then potassium chloride at the store. They call it salt substitutes, so that sodium will raise your blood pressure. That's why we talk about not eating a lot of salt. You can still get a lot of salty taste with this blend here. All right, so here, these other twos are actually in chemical form. A hydrogen chloride plus sodium hydroxide yields water, and there's your salt. Nitric acid, that's a nitrate, but we call it nitric acid. And potassium hydroxide, the hydroxide group makes it basic, yields water plus a salt. All right, so students tend to have not a whole lot of problem with that. Water is one of those. You've got to have water coming out of it. All right, then combustion. Ink, and this is our final type. Combustion reactions. Combustion reactions involve some sort of burnable product. This is a hydrocarbon. Hydrocarbons burn well. This is butane gas. This is what's in your little portable lighters, pocket lighters. This is butane. So you've got some hydrocarbon. You see, if you see CH something something, that should be your immediate trigger that you've got a hydrocarbon and therefore a combustion reaction. Plus oxygen. We need lots and lots of oxygen. We need some sort of ignition source. It's an exothermic reaction. Exothermic. Puts out lots and lots of heat. That's why we burn hydrocarbons. Once you get the reaction going, as long as there's fuel, as long as there's a hydrocarbon, you're going to keep burning. So the two products are carbon dioxide in this case, and water. You're always going to have water. You get carbon monoxide out of that also, but that's your main constituent, carbon dioxide plus water. So we see water in two places. We see it in the neutralization reaction. So double check, okay, I've got water, it's either neutralization probably or combustion probably. Which is it? Then go look for your hydrocarbon. Okay, and in our final minutes, that's the last. Go back to the front slide. And I will type this up and have it more formal and in a rubric, which you'll know what I'll be looking for in the slides. But basically, you're going to be giving me 2 each type with a paragraph describing the reaction, 30, 40 words, something like that. Paragraph describing the reaction. You want a graphic of the chemical reaction, of the reaction. Graphic of the chemical reaction. And again, you're going to be looking for something like, you know, these molecules yields some big mess here. You know, that kind of thing I showed you earlier. That's got 6. This will be due close of the period on Wednesday. Close the period of Wednesday. So a graphic, and if you can find some picture, and most likely, maybe that's the product, a picture of the product. Like magnesium oxide or something, like a combustion reaction, you know, have a house burning or something. A synthesis reaction, decomposition. See if you can find something. This one's the abstract part. I'll go light on this one. But that will certainly help your case. All right, so tomorrow you will get a handout with your 5 German bonus questions to research. And then when you get the actual bonus questions, they'll be sorted in a different way, so you don't just memorize the answers. And then get you started in the PowerPoint. We'll be going right to 127 tomorrow. I'll put a sign in the door. Too much work. All right, and I will see you guys hopefully on Thursday. Hopefully all will go